So we were discussing on the limitations of working stress design method. So the criteria that ensure that the stresses will not go beyond the yield stress values itself includes some limitations in the working stress design philosophy. Why? Because the yielding at a single point does not lead to the collapse of overall structure or overall member. That means if yielding starts from a single point in a beam, that doesn't mean that starting of the yielding will suddenly collapse the beam. Okay, it is a systematic process. It is a systematic process. Okay, so there are some steps involved in it from technical point of view. So ultimately, the thing is that there will be no sudden collapse, and after yielding, there is a systematic process of developing cracks and their propagation. Okay, so no basis for factor of safety, and it is different in actual practices. So the factor of safety, what is being used, is not been clearly defined by the working stress method design philosophy. That how someone can take this factor of safety, whether we have to use a constant value or we should change it. Okay, so there is another limitation due to this factor of safety. Okay, the third thing is that the redistribution of moment is not considered. That is what I was talking in the very first point of yielding at single point does not leads to collapse. And that means that there is a systematic procedure, and that includes the redistribution of moments. What is this redistribution of moment? It is something like, if you all have learned the basics of shear force diagram and bending moment diagram. आप सभी को पता है बेंडिंग मोमेंट डायग्राम क्या है, बेंडिंग मोमेंट्स कैसे आते हैं. बेंडिंग मोमेंट डायग्राम की जब आप बात करते हैं तो सबसे इंपॉर्टेंट चीज आपका है क्रिटिकल सेक्शन, right? So bending moment will just showing that within which portion of the beam, within which portion of the column for which we are preparing the bending moment diagram. Okay, within which portion of that member the stresses are the bending stresses. Actually, the bending stresses are very high, and for which portion the bending stresses are not so about to worry. Okay, so this is the basic aim behind the bending moment diagram and shear force diagram. Okay, we all have studied the flexor formula. Okay, that m upon I equals to sigma upon y equals to E by R. सभी जानते हैं बेंडिंग इक्वेशन फ्लेक्सर फॉर्मूला.
हाँ सर.
Yes or no?
Yes sir.
Okay, from that formula or from that equation, the sigma that describes the bending stress, and that is related or linked up with the bending moment, that is m value. Okay, so bending moment is just showing that within which portion of the member itself there is the higher chances of extreme, we can say that, bending stresses. Okay, so sigma b, that is bending stresses, that depends on the moment. Okay, so again, if for a particular beam the bending moment is maximum at a particular section, that section will be known as critical section. I think you are all aware with that point. If not, please learn this, that this is the critical section from bending moment point of view. If you are talking about shear force, then if at any certain section of the beam, if the shear force is maximum as compared to the other location, other sections of the same beam, okay, then that point or that section will be recognized as critical section for shear point of view. Okay, similarly we have critical section for torsion, bending moments, and whatever not. Okay, so what we are focusing is on the bending stresses indirectly with relating them with the bending moment. Okay, so what happen if for a simply supported beam, we all know that the critical section lies where? कहाँ होता है क्रिटिकल सेक्शन? मैक्सिमम बेंडिंग मोमेंट कहाँ होता है सिंपली सपोर्टेड बीम के लिए?
बीच में, सेंटर,
एट द सेंटर ऑफ द बीम.
सेंटर में
कितना होता है? हाउ मच? मैग्नीट्यूड कितना होगा उसका फॉर अ यूडीएल केस? Please learn all these things. It will be WL square by 8. That W is the uniformly distributed load on the entire span of the beam. L is the span and 8 is constant. So WL square by 8. And in case of point load, it will be WL by 4. So these are important values. Please remember this. Okay. So WL square by 8 will be the maximum bending moment, and it will be at the center of the beam. Similarly, for the fixed beam, we have different values, WL square by 12, WL square by 24 at the ends and all those. ठीक है, तो यहाँ से आपको क्या समझ में आएगा वो देखिए कि आपकी जो भी वैल्यू है मैक्सिमम, वो वैल्यू किस सेक्शन पर है, दैट विल बी योर क्रिटिकल सेक्शन, फर्स्ट थिंग. सेकेंडली, if that moment is being reached, that if 4 simply supported beam at center WL square by 8 is reached, in that case what will happen, the beam will goes to collapse or it will stay for some time. See, there is no sudden collapse in the beam even after reaching the WL square by 8, that is the maximum bearing capacity from moment point of view. Okay, so the crack will be generated in somehow a systematic procedure that after attending that moment of WL square by 8, the nearer section that are less stressed in the initial stages of loading, the moment will be redistributed in those segments of the beam. Okay, so moment will be redistributed to those cross section which are less stressed. Okay, that means we are redistributing the moment. It is by the nature of the beam itself. Okay, it is by the geometry of the beam. That means even after reaching the maximum bending moment, the beam will not leads to collapse and it will be sharing the moment within the lesser stress sections. Okay, so eventually the moment in the lesser stress sections will be increasing after increasing the loads beyond the WL square by 8 capacity. Okay, so when those sections attend their critical limits, in that case what will happen, the cracks will propagate. Okay, so at WL square by 8 there will be a crack in the tension zone, especially in the tension zone, that is the bottommost portion of the beam or bottom fibers. Okay, after even reaching the bending moment, maximum bending moment values of WL square by 8, the beam will be sharing its moment, that if further there is increase in moment, the moment will be shared among the less stress section. Okay, so that is called the redistribution of moment, and that was not considered in the working stress design philosophy. Again, structural material can't be linear and elastic in field condition, in actual condition. Okay, so leads to non-linear behavior, and again it will require a non-linear analysis, not like the analysis what we have considered in our previous lectures. Okay, so consideration making it a big question mark that it should be adopted or not in the field, but the results have shown that the research work has shown that it gives satisfactory section due to the higher serviceability, the only advantage of working stress design philosophy. And again I will add on that why we are using it till today is its serviceability. By means of serviceability, that means the sections are quite thicker. By default, if we are underestimating the strength of the material, okay, we are underestimating the strength. The concrete what we have, we are considering it to be of lower grade. Okay, that means for M20 we are not considering that it will be going to be delivered to 20 Newton per mm square. It is somehow considered as at lesser values. In that case, what will happen? The margin is quite higher. That means we are considering very much underestimating it. Okay, so in that case the margin is quite higher between the actual values and the considered values, and that will leads to uneconomy in the overall construction. Okay, so these are some limitations of working stress design method. But again, what I have said that it has good serviceability, and it is the only reason why we are using it today. Okay, so by the construction of these thicker sections after following this design philosophy. Why thicker section? Because to resist the same amount of loading, as we are considering less strength of material, will be requiring more and more materials. आपने मटेरियल की स्ट्रेंथ को कम वहां पर लिया है, कम कंसिडर किया है. सपोज एक्स स्ट्रेंथ उस मटेरियल की थी, आपने वहां पर एक्स माइनस 5 कंसिडर किया है, तो उस मटेरियल का अमाउंट आपको इंक्रीज करना पड़ेगा, सेम अमाउंट ऑफ लोड अगर आपको रेजिस्ट करना है तो. इन दैट केस व्हाट विल हैपन, you have to add on the material, and when you are adding the material, especially the steel, okay, when you are using more and more material, the structure will be not economical. Okay, and that leads to uneconomy. Again, the members will be of thicker size. Okay, the member will be of greater sizes, and the greater size will allow the serviceability in the entire structure. And by means of serviceability is that See, the failure does not happen on the collapse load or on the final load or on the maximum load carrying capacity of the beam or column or slab or whatever the member is. Okay. The thing is that we have to design for the maximum load capacity, but we should check it on the working or service load too. Okay. We should check it on the working loads. That means there are possibilities that the structure may collapse due to vibration. It may fail due to fire. Okay. It may fail due to any other phenomena other than those conditions which are directly related with the collapse. That is the overturning, that is the flexural values, tension capacity, compression capacity. Okay. So these are the things. So while we are talking about serviceability, you can understand it in simpler terms that it is somewhat related with the comfort of the occupants in the building. Okay. So by means of serviceability, that means if you are sitting in a room and suddenly you see a crack in the wall or in the beams, it will gives you a discomfort. Okay. So there is some scary feelings, and that is not good for the structural designer that they design in this manner. Okay. So we should consider the serviceability. So that is not something which is related to the collapse of the structure. But even the structure is not collapsed yet, but it is failed to fulfill the criteria of serviceability. That means the structure is not able to do or to act for the purpose for which it was intended and created. Okay. So that is overall about the working stress method and design philosophy. So we have different methods as I stated earlier. So the second one is the ultimate load method or the plastic design theory. So in that case, see, we'll be comparing it with the working stress method. Firstly, that in case of working stress method, that was covertly an elastic approach, but ultimate load method and limit state approaches are plastic methods. Okay. First point. The second point is that here there will be no consideration on the material strength. Only and only thing what we are focusing in this method is the load criteria, the loading pattern. So we are just controlling the loading on the structure by introducing a mathematical parameter, that is the load factor. Okay. So load factor is what that we have over stress the loading. Okay. Loading conditions. That means we in the previous case of working stress design method, what we have considered is the lesser strength of the material. In this case, what we are doing, we are assuming higher loading on the structure. Okay. Higher than what there may be actual loading. Okay. So in this method, a load factor is introduced. The load factor can be given by, you can write it as, see here, that is written ultimate load divided by working load. Okay, that is the load factor. Means for a certain value of ultimate load, what you can do is the load factor. Suppose this value is 1.5. This 1.5 will be multiplied by the working load to obtain this ultimate load. Okay. So that's how the load factor will work. It will exaggerate the loading somehow what it exists in real site condition, real field condition. And if you are designing for higher loads, obviously it will be safer for the lesser load values. Okay. So that is the basic principle of designing this philosophy. It includes the non-linear behavior, as I have already mentioned that it is based on the plastic design theory. That means it includes non-linear analysis, but in this method, no such non-linear analysis was carried out, and that is one limitation of this method. Factor of safety for different types of load is considered. Okay. But it was limitation, the same point was limitation for the working stress design philosophy, because in working stress design philosophy we have single factor of safety and there is no such description and explanation with regarding that factor of safety. Okay. So from where that factor of safety is coming, what value should be adapted, it should be changed or not, so that are all question mark in the working stress design philosophy. But in case of ultimate load method, the different factor of safety for different types of load, that is for the dead load, live load, earthquake load, wind load, that are being introduced. Okay. So these are important things about this method. Again, the limitation, if we talk about limitations, that serviceability cannot be guaranteed, but the strength is there in this type of method. It is just opposite to what we are understanding in the working stress method, the previous one. Okay, so in the working stress method, what was there, that the serviceability is higher. Why? Because the sections are thicker. So oppositely here the sections are thinner. Why sections are thinner? Because we have not adjusted the strength of the material. That means we have not worked out on the material capacities. What we have done is entirely dependent on the loading conditions. Okay, what we have changed is only that loading conditions. Okay, so the serviceability will not be there, but yes, the strength can be guaranteed in this method. Again, nonlinear analysis was should be performed, but it was not performed, and that is one limitation of this method, as I have discussed. And less serviceable sections, because slender sections, thinner sections are there, and that leads to certain we can say that deflections, higher deflections, and bendings and all things happen there after stressing those sections under the actual site conditions. Okay, so these are the limitations of this method. Again, the third one, the very practical approach, what we are using in the present era is the limit state method, the limit state design philosophy. Okay, so what we have learned till now, if you have any doubt, you can ask here. आपको कोई भी दिक्कत है तो आप बोल सकते हैं. कोई चीज समझ में नहीं आ रही है तो पूछें उसको. Is it clear?
सर प्रेजेंट में अपन लिमिट
Both
स्टेट काम में
methods are clear. Working stress method. Yes, please.
सर अपन प्रेजेंट में लिमिट स्टेट काम में ले लेना.
Yes, yes. We are following the limit state.
और सर वर्किंग
That is one limitation, what we have discussed. That factor of safety is not clearly defined in this method. Only we have considered that value. But from where that value is coming, what should be its basis, that are not, that whole thing will not be discussed. Okay.
ओके सर.
Okay. Any other doubt? Okay. So let us proceed toward the limit state method. This approach is entirely different from the two what we have learned previously. How it is different? See, it incorporates all the challenges that a structural designer have faced. Okay, or have to face all the time whenever he is dealing with a certain project, with a particular project. Okay, so what are those challenges? The very first is the variability of the strength of the materials, the variability of the loading conditions, what we have studied in the initial stages of this course, that concrete is a variable material, loading is even variable on the structure. So those all things are making the structure to be somehow challenging for the structural designer. Okay, so again we are using a word here, that is the structural fitness. Okay, we know the meaning of the word fitness. I'm using the word as a structural fitness. That means what this structural fitness is, you can consider it like the, as we have discussed earlier, that not only the failure will be considered after reaching the maximum load carrying capacity, but on the same time the failure can be considered for the conditions which are creating cracks in the structure, which are creating excessive vibrations in the structure, which are creating excessive deflection in the structure, even though the structure will not be collapsed right at that point of time, but the structural members will not be considered as fit. Okay, the structural members were or will be unfit. Okay, that is important, that the structural fitness what it is. Okay, 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 I am repeating. देखिए स्ट्रक्चरल फेलियर जो आपका हो रहा है, इतना आप उसको जनरल टर्म्स में ऐसे ही नहीं समझ सकते हैं कि जब आपका मैक्सिमम लोड आपके स्ट्रक्चर पे आ गया है, वहां पर क्रैक्स जनरेट हो गए तभी वो फेल होगा, ऐसा नहीं है। फिटनेस से मेरा मीनिंग बेसिकली ये है कि आपका स्ट्रक्चर ऐसा नहीं है कि सिर्फ मैक्सिमम लोड पर ही फेल होगा, उससे पहले भी हो सकता है कि आपके बीम के अंदर डिफ्लेक्शन काफी ज्यादा हो गया हो सकता है वहां पर टेम्परेचर के कारण कुछ चेंजेस हो गए हो सकता है वहां पर फायर के कारण कोई थ्रेट हो सकता है वहां पर वाइब्रेशंस एक्सेसिव हो, डिफ्लेक्शन एक्सेसिव हो, तो ये सारी पॉसिबिलिटीज हैं। तो इन कंडीशंस में भी आपका स्ट्रक्चर क्या कहा जाएगा कि वो फेल है, न सिर्फ जब आपका स्ट्रक्चर क्रैक जनरेट कर रहा है या स्ट्रक्चरल फेलियर दिखा रहा है तभी उसको हम कहें कि वो आपकी डिजाइन फेल है, ऐसा नहीं हम मानेंगे, हम हर केस को लेकर चलेंगे यहाँ पर। सो वी हैव यूज more general term, that is structural fitness. Okay, so I'm not using the word collapse or serviceability, I'm using structural fitness that describes both of these things. Okay, that means the structure is protected from collapse as well as on the same time it is giving better serviceability. Okay, so collapse is something at the ultimate load or maximum load on the members, and the serviceability is related to the working loads or normal loading conditions, service loads. Okay, so these are all the things. Apart from that, economy and durability are there. So we have to consider these two terms also. Okay. So as of now, as we can say that as an undergraduate student, you should not be worried about economy, but you must know all the principles that will maintain the economy in the structure. इकोनॉमी कैसे आप मेंटेन करेंगे मैं आपको बताऊंगा, बहुत सी चीजें मैं आपको बता चुका हूँ कि इकोनॉमी आप बस इतना सा ध्यान में रखें। सबसे इंपॉर्टेंट चीज जब आप डिजाइन की बात करते हैं तो आपके पास स्टील है जो आपको कंट्रोल करना है, द अमाउंट ऑफ स्टील व्हाट यू आर प्रोवाइडिंग। ओके, सो आप स्टील को कंट्रोल कर सकते हैं, दैट मीन्स आप इकोनॉमी को कंट्रोल कर सकते हैं। ओके, बट नॉट एट द कॉस्ट ऑफ सेफ्टी, सेफ्टी के साथ आपको कोई समझौता नहीं करना है। ठीक है, इकोनॉमी आप प्रोवाइड कर रहे हैं, दैट इज गुड थिंग, बट इट शुड बी सेफ। Okay, so all those things, that uncertainties of loading, material strength, performance, designer has no direct control. We have no direct control on those things. Okay, there is no actual systematic procedure following which I can control the variability of the material. Okay, so what we do in the design procedure is the only thing is to keep the risk as less as possible. Okay, so we are keeping or we are controlling the risk to the lowest values. And how we are actually considering those risks? See, in the earlier methods, even though the risks are minimized, okay, the same fundamental was used by the earlier methods, that in the working stress method, the values of the stresses are considered to be lesser, or the values of the strength of material is considered lesser actually. Okay, there is no such control on the loading in the method. Again, in the second one, what we have studied in the ultimate load method, we are focusing on the loading condition and not on the material strength. Okay, so again, in both of these methods, we are somehow escaping from one of the important parameter of the design. That is, for the very first one, for the elder one, for the oldest method, what we are escaping is the loading criteria. For the second one, ultimate load method, what we are escaping is the material strength criteria. So limit state, what limit state method does basically, it considered both of these things, that is the loading as well as the material strength. Okay, so this is important that the method consider both of these things and design the structural members to somewhat reflecting more realistic condition, more we can say that more actual conditions that reflecting the site or the members, how they are going to be loaded on the site. Okay, so these are the whole this is the whole scenario for the design philosophy by the limit state method. Okay, so single value for each load and for each material property is assessed. First of all, how we'll know the single value, even our material is variable. आप लोगों से मैं डिस्कस कर चुका हूं प्रीवियस क्लासेस में, थोड़ा सा माइंड को आपको चलाना पड़ेगा। आरसीसी की क्लासेस आप अटेंड कर रहे हैं तो अदरवाइज आप समझ नहीं पाएंगे इन चीजों को। तो आपको मैंने बताया था लास्ट टाइम कि वेरिएबिलिटी होती है कंक्रीट के अंदर, वेरिएबिलिटी होती है लोडिंग के अंदर, वहां से एक सिंगल वैल्यू पे आपको आना चाहिए। सिंगल वैल्यू पे जब तक आप नहीं आएंगे आप मैथमेटिकल प्रोसीजर में नहीं आ पाएंगे। तो वो सिंगल वैल्यू पे आप कैसे आए थे, किसी को याद है क्या मैंने बताया था उस समय आपको?
सर क्वेश्चन रिपीट करेंगे?
ओके, मेरा क्वेश्चन ये है कि आपका कंक्रीट एज अ मटेरियल इज क्वाइट वेरिएबल, आप उसकी एक स्ट्रेंथ नहीं बता सकते। लाइक आप M20 भी बोल रहे हैं तो आप नहीं बोल सकते कि M20 यानी कि 20 उस स्ट्रेंथ उसके अंदर आ ही जाएगी फाइनली। ओके, सो इट इज वेरिएबल। अगेन लोडिंग की बात करते हैं तो अगर आप बोले कि एक्स अमाउंट ऑफ लोड इस बीम के ऊपर आएगा तो दैट इज अगेन कैन नॉट बी कांस्टेंट वैल्यू। ओके, सो दिस आर ऑल वेरिएबल्स। वहां से आपको एक कांस्टेंट वैल्यू पर आने के लिए आप जो वैल्यूज कंसीडर करेंगे उसके लिए आप क्या करेंगे, ये चीज मैंने आपको लास्ट लेक्चर्स में बताई थी। आई थिंक दैट वाज द सेकंड और थर्ड लेक्चर ऑफ आवर सीरीज। तो आप में से किसी को याद है, कुछ पता है उस बारे
यस
में?
सर। सर
यस
मॉड्यूलर
प्लीज
रेशियो।
एक्सप्लेन। बेटा डरो नहीं, एक्सप्लेन करने से गलत ही होगा, इससे ज्यादा कोई दिक्कत नहीं होने वाली, ठीक है? लेकिन आप थोड़ा सा इंटरेक्टिव रहेंगे तो एक तो मुझे पढ़ाने में मजा आएगा और दूसरा ये पता चलेगा कि आपकी गलतियां कहाँ हो रही है, ठीक है?
सर
यस
मॉड्यूलर
प्लीज
रेशियो। मॉड्यूलर रेशियो।
यस यस यस। मॉड्यूलर रेशो से नहीं रक्षित, उससे पहले हमने बहुत कुछ पढ़ा था एक सिंगल वैल्यू पर आने के लिए। वी हैव स्टडीड द टर्म कैरेक्टरिस्टिक स्ट्रेंथ, कैरेक्टरिस्टिक लोड।
Characteristic
आपको याद है या
load,
नहीं?
फैक्टर ऑफ सेफ्टी।
sir, characteristic load
नो,
95%
फैक्टर ऑफ
probability
सेफ्टी
of
इज अगेन
not.
different thing.
हाँ
The factor of safety is something which is maintaining the structure to be reached out for the maximum stressed values. Okay, that is different thing. We are maintaining a margin of safety there. Factor of safety is different thing. Yes, Medhavi.
Sir, characteristic load जिसके अंदर पड़ा था 95% probability of not being exceeded during the lifetime of the structure.
Exactly, exactly. Good, good. And for the material strength, anyone can explain, please, characteristic strength.
सर कैरेक्टरिस्टिक स्ट्रेंथ ऑफ मटेरियल।
Yes.
Nominal
सर
strength of the
90 मतलब 100 में से सर 96
amount of strength.
परसेंट मतलब सर सैंपल की है ना स्ट्रेंथ सेम हो तो सर कैरेक्टरिस्टिक स्ट्रेंथ हो।
Yes, Harshvardhan is going right. Yes. Okay. So characteristic load. See why we are studying these parameters: characteristic load, characteristic strength. Actually, there is variability of high amount of variability is there. We all know that we cannot come to any particular value of loading. We cannot come to any particular value of the strength of material. So what we are doing is basically we are estimating those values that this value must be the safest value if we consider as a single point value. Okay, so if I do not consider the variability, okay, and variability in the loading, that mathematically that I am not defining a range that from 20 to 30 kilonewton, I am saying that 25 kilonewton, that is a point of loading, not a range of loading. Okay, so this is a difference, that from variable loading we have just arrived onto the characteristic load. Okay, so variation in the loading, that is a range of loading. Okay, so we do not know the exact range, exact value, and till we know we are not on a single value of loading, will not be able to design the structure. So what we have done is we have introduced the characteristic loading parameter. That means it is that load on the structure that has 95% of probability of not being exceeded in its entire life. Okay, that means if you are, suppose you are designing a structure for 50 years, for 70 years, and you have said that the characteristic load value is X kilonewton, that means the structure will not face the load that are greater than X kilonewton in its entire life of 50 to 70 years. Okay, so that is important thing, that we have appeared on a single value from a range of values. Is it clear to all?
यस सर।
Yes, sir.
Okay. The similar thing goes with the strength criteria. What is the what was that strength is again variable. So nobody can actually describe that if you have designed for M25, then M25 that exactly 25 Newton per mm square will be in the field that will be delivering. Okay, but there exists some variability. It may be 22, it may be 27 even, it may be 23. Okay, so there are variabilities. Now for design point of view, if I have to appear on a single value of the strength, I should go with the characteristic strength value. Okay, so for that, what we have defined is which has 95% of probability that which has probability that 95% of the samples are showing that value. Okay, so that is the characteristic strength. So for any material, it is that strength or it is that value of strength that has possibility of in case of 100 samples, there is possibility that only 5% of samples will fail and 95 will be passing through this value. Okay, so we have somehow fixed the values from the variable values to a constant fixed value. Okay, so that is the whole thing. That is the importance behind this term, characteristic strength and characteristic load. Okay, so that are all a part of the limit state design philosophy. Okay, these all things are been described in the limit state design philosophy. In the earlier design philosophy, there were no such parameter. Okay, so what we are doing is we are just overestimating, sometimes we are underestimating, but this is the thing which will give you perfect values of strength and load on the site condition. So this is more realistic to the methods what we have considered earlier. Again, economy and safety will be there because you have considered the actual loading, and after, see, we are not going to use this actual load. We are going to obtain design load on the basis of this actual characteristic load. Okay, we'll not be using even this term of actual load. We'll be using characteristic load. Okay, that means a load which define the characteristic of the overall loading that will be on the structure on its entire life. Okay, characteristic strength, that means a load, a strength value that will describe the character of the strength that the material possesses. Okay, so after knowing this whole thing, why it is helpful and what it is give to us, that it gives us economy and safety in terms of the maximum permissible load. See, we are not going to use this characteristic load in our mathematical calculation, but we are using design load. That design load is obtained with the help of this characteristic load. So we'll use a partial safety factor to further increase this characteristic load. Okay, to further overcomes the variability in the design process. Okay, the uncertainties in the design process. What we are using is the partial safety factor. In the working stress design philosophy, we have used factor of safety. Remember this thing. In the earlier method, we have used factor of safety. In the second method, we have used load factor. But in the third method, the term is the partial safety factor. All of these three things are similar, but not same. Okay, these things are similar in terms of providing the marginal safety in the structure. Okay, limit state design method, we are going to use partial safety factor. See, the factor of safety works for the material strength value. Okay, please note, factor of safety work for the material strength value. It will control the material strength. The load factor will work for the loading. That means it control the loading. Okay, loading values can be controlled. The third one, the partial safety factor. The partial safety factor will control both loading as well as the strength. Okay, so again, the same thing that in this method, we are controlling both of these things, that loading as well as the strength of material. Right? Is it clear?
Yes, sir.
Yes, sir.
Okay. So giving the time, I think it will not be good to go with the partial safety factors, but right at this point of time, we can understand what is limit state. So mathematically or technically, we can say it sounds good more when we say technically. So technically, the limit state can be defined as acceptable limit of safety and serviceability. You all must remember this definition. It is very important, not only for from Viva point of view, from interview point of view, from gate point of view. From it is overall describe what you are learning in the RCC. Okay, so it is important definition. Please note down it. It is the acceptable limit of safety and serviceability beyond which a structure is not fit for the intended purpose. Please read this definition more clearly. Acceptable limit, that means beyond these values, we are not going to adopt higher values, and we are considering that the structure will be failed beyond these values. Okay, so that is the acceptable limit of what it is, of safety as well as serviceability. That means it is maintaining both of these things, and not we can say that unlikely what we are doing in the previous methods, that some in methods we are obtaining safety, in some methods we are obtaining serviceability, but in this method we are focusing on both of these two terms. Okay, so we are going with the acceptable limit of the safety as well as serviceability, beyond which a structure is not fit. Please note down the word fit, structural fitness, that what I have described in that point. Okay, beyond which a structure is not fit for the intended purpose. Intended purpose means, suppose you are designing an assembly building. Okay, you are designing an exhibition hall. What will be the purpose of that hall? It should allow gathering of people. Okay, so if by doing so, if allowing the gathering of people will somehow we can say that challenge the serviceability of the structure, that means it is not serving the purpose for which we have prepared the structure. That means it is failure. From serviceability criteria, it is failed. Okay, not I'm not saying that the structure is collapsed, but it is failed from serviceability criteria. Okay, is it clear to all?
Yes, sir.
So the structure may fail due to serviceability criteria, and it may fail due to the safety criteria. Yes, please.
सर ये एक्सेप्टेबल लिमिट ऑफ सेफ्टी फिर से बताओ ना क्या होता है?
Acceptable limit of safety, that means we are talking in terms of mathematical parameters. That is what value of loading should be considered. And serviceability, that means what values of deflection, what values of vibration, what values of fire resistance should be considered. Okay, so these are all things that is the acceptable limit. That means we should not go beyond these values. In working stress method, what we have done, that we are focusing on the permissible stresses, and we are ensuring that nobody we are going values, right? So here in this method, what we are doing is we are limiting ourselves to this acceptable values, and we are not generally call it acceptable values. We are using the term limit state, that itself shows these are the acceptable values. Okay, is it clear?
Yes, sir.
Okay. See the PPT, what you are seeing on your screen is a rough lecture note. Please don't follow it. I will give you the complete notes regarding to this chapter and the previous ones. Okay. It is a kind of lecture note. So please do not follow this. You can also access to our educational blogs. Please visit our website www.civilabhyas.com. These are the services in which we are dealing professionally. Please do like our videos, subscribe our YouTube channel, and share it with your friends if you find this content helpful for you. Thank you.